In this video, we're going to be looking at showing that side, 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 or triple S, are sufficient to describe one triangle, which just means that any two triangles that share a side, side, side congruency relationship are themselves completely congruent. To do that, we're just going to start off with a straight arbitrary line, okay, and some line segment AB for one of the sides. Okay. Completely arbitrary, we're just going to make those. Okay. So we have this particular length. We're going to arbitrarily shorten it to some other random length and draw a complete circle about B, and then we're going to make an even different circle about A. Okay? So they don't have any of the same length relationships, so there's nothing particularly special about any of these. They're not the same length at all. But what we find is that for a given triangle with three sides known, okay, i.e. a segment, a radius, and another radius, there are only two intersection points. One up here and one down here. Okay? Those each construct a triangle. This is C, this is D. We construct the triangle ADB, and we construct the triangle ACB. So we note that there is only one particular type of triangle that can be created from knowing three sides. Again, we have arbitrarily chosen three different side lengths. It will not matter what we choose. The only condition is that there is an actual intersection point. If the circles get further and further apart, all of a sudden they're not going to intersect anymore. Imagine that you had, of course, this circle and a radius of this one which didn't touch it. No triangle would be created. If this one was too large, okay, it would go around the other circle, and also no triangle would be created. But everywhere else you can always create two triangles, and by inspection they are actually congruent themselves. Okay? Why might that be? Well, these angles are bisected. Okay? So the two angles, these should be different angles necessarily. If two of the angles are congruent, the third angle must also be congruent, and all three sides are congruent. Because every part of this triangle is congruent with the other one, we know that these two triangles are actually the same triangle as far as they are congruent. Okay? So in this way we have just demonstrated that there is only one possible triangle that you can draw from knowing three side lengths.